So this is lesson 9, continuing on with the second section of unit 1, which is powers. So today we're going to be talking about multiplying and dividing powers. So again, we have a little bit of vocabulary. This vocabulary is vocab we've already been using. So we have 2 to the x, should be familiar. 2 is the base, x is the exponent, and the whole thing is referred to as a power. Okay, so we're going to be going through, again, 3 different rules. 3 different rules: the multiplication rule, the division rule, and the power of a power rule. And they're really straightforward, and just like the rules we looked at 2 lessons ago, they're actually based on understanding how exponents work, which means if you forget the rule, you can always figure it out from first principles. So let's start with the multiplication rule. So the multiplication rule says that when the bases are the same, I'm going to put that in capital letters, really important, the bases have to be the same, the exponents just get added together. So in algebraic terms, it looks like this, all right? A to the n times a to the m is a to the n plus m. You just add the exponents. And remembering that whenever you see those brackets side by side, so we've got a to the n and it's side by side with a to the m, that's a multiplication, okay? And I know that can sometimes be confusing, but you have to remember that's telling you to multiply those together. So let's look at why this actually works. So 3 to the exponent 2 times 3 to the exponent 2. Well, what is an exponent? An exponent is repeated multiplication. It's telling you to multiply the base that many times. In this case, 2 times. So 3 to the exponent 2 is 3 times 3. And 3 to the exponent 2 is 3 times 3 again. And I'm multiplying them together. So what I'm actually getting is 3 times 3 times 3 times 3. But hold on. When you multiply something together multiple times, that's what an exponent is. How many times am I multiplying it together? So the base in this case is 3, right? Because that's what we're multiplying together. And how many times are we multiplying it together? We're multiplying it together 4 times. So the answer is 3 to the exponent 4, which is the same as 3 to the 2 plus 2. So it follows the rule. So let's try this again. So the base is -2. We're going to add the exponents together because that's what the rule is telling us. So we've got one exponent here is the 2, but what exponent's over there? Right, that's our sneaky secret exponent 1. Okay, so I have 2 plus 1, which is going to give me -2 to the exponent 3. Now on an assessment, when you see things like this, you'll also see some wording that says, evaluate all exponents if possible. Evaluate all exponents means you bring them to a final numerical answer. This, okay, let me change colors. Okay, this as an answer is a simplify. If you see simplify, it's asking you to put it into its simplest form, which is 3 to the exponent 4. But if you see evaluate is going to tell you to bring it to a numerical answer. So in this case, 3 to the exponent 4 is 81. So if I say this equals 81, that is in response to a question that says evaluate. Okay? So what is -2 to the exponent 3? Let's think about our negative rules. We explored this a little bit in the rational numbers. -2 to the exponent 3, it's negative inside the bracket, so it is affected by the exponent. Is the exponent odd or even? It's odd, which means that our answer is going to be negative 2 to the exponent 3 is 8. Negative 8. So that's the multiplication rule. What about the division rule? So the division rule says when the bases are the same, remembering the same being very important, subtract the exponents. When the bases are the same, subtract the exponents. So let's look at this algebraic form of the rule. If we're going to give a general form, right here, a to the m over a to the n is a to the m minus n. And why does that work? Why does that work? So remembering that if we had a divided by a, that equals 1. 1 divided by 1, 1. 4 divided by 4, 1. 10 divided by 10, 1. So any number over itself is 1. So let's look at a to the 3 over a. Let's expand that exponent. That's going to give me a times a times a, and it's still over a. Now, I can, because it's all multiplication. This doesn't work if there's addition and subtraction in there. You can't do it. But because it's multiplication, I can use cancellation. Remember, we talked about cancellation when we were doing our order of operations and our multiplying and dividing fractions. We talked about cancellation. So we can perform cancellation. So a divided by a is 1. So they're going to go away. And what I'm left with is a times a. And a times a is a to the exponent 2, which is the same as 3 minus 1, which is what the rule tells me. So the rule is only a short form for the actual long way of doing something. So let's look here. So the rule would tell us, let's solve this in 2 ways. The rule would tell us that this is 2, because that's the base. And then we subtract the exponents, and you always put the numerator exponent first. So the numerator's exponent here is 3. The denominator's exponent is 2. And then what we're going to get is 2 to the exponent 1, which is 2. And on an assessment, you could write 2 to the exponent 1. I wouldn't take any marks off for it, though the more proper way of writing it is just to write the number 2. Or we can do this the long way. We can say 2 to the exponent 3 in the numerator is 2 times 2 times 2. And 2 to the exponent 2 in the denominator is 2 times 2. Then we're going to do some canceling. So I've got a 2 on the top and the bottom. 2 divided by 2 is 1. 2 divided by 2 is 1. What am I left with? Just 2 on top. If you were left with 2 on the bottom, your answer would be 1 over 2. And that's totally fine. You're allowed to have 2 on the bottom. That's no problem. Okay? So you can see the rule is much quicker. But in order to use the rule appropriately, you really do have to understand why the rule works. So that's what I'm trying to show you also. So let's look at another one. We're going to use the rule to solve this. The base is negative 4. The numerator exponent is 4. The denominator exponent is 2. You're going to get negative 4 to the exponent 2. What is that? When it is evaluated, when you evaluate it, you say, okay, negatives inside the brackets. Exponent is even. So you're going to get 4 squared, which is 16. So your answer is 16. So far we've used real numbers, whole numbers, but let's look at these with some variables. Okay, so the very first thing I want you to do is identify the base. The base in this case is negative x. So negative x, then we're going to look at what rules are in play. So negative x to the exponent times negative x to the exponent. It's a multiplication rule, so I'm going to add 2 plus 5. I'm going to get negative x, keep it in brackets. The brackets change the answer to the exponent 7. Now I cannot evaluate this. I don't have a final numerical answer because I don't have anything other than variables in here. So I'm just going to leave it like that. Let's look at the next one. So here I actually have multiple rules happening at the same time. Multiple rules happening. I have both division and the multiplication rule. So depending on how many rules are happening, it depends on how many steps I'm going to use. I'm going to use 2 steps. So first, I'm going to do the multiplication rule step, and I'm going to say on top I have x to the 5 plus 3, and on the bottom I have x to the 4 plus 2, and that's going to give me x to the 8 over x to the 6. Am I done? No, now I'm into the division rule. So my base is still x, my numerator exponent is 8, my denominator exponent is 6, and I'm going to get x to the exponent 2 as my final answer. Okay, let's do one last question. This one is more complex because I'm mixing your whole number bases in with your variable bases. So now I want you to pay really close attention. In this case, I can do the division first. That's not a problem. And really, there's no multiplication on the top and the bottom. So I'm going to do division. So how many bases do I have? I have 2 as a base, I have x as a base, and I have y as a base. So I have 3 bases. So let's look at the 2's. Okay, it's a division, so it's going to be subtraction. Numerator minus denominator. X is going to be 7 minus 4, and y is going to be 3 minus 1. So I'm going to have 2 to the exponent 3, x to the exponent 3, y to the exponent 2. Am I done? Almost. I'm very close to being finished. That base 2 needs to be evaluated all the way to its numerical ending. So I can evaluate part of it. And to fully simplify, you are going to evaluate any of your integer bases. 2 to the exponent 3 is 8. x3 doesn't change. Y to the 2 doesn't change. So the final answer is 8x cubed y squared.